Today we are going to learn design of experiment. It's a follow-up video. We are going to construct the basic part like how to do, when to do a design of experiment, what are the elements we need to keep in mind, and various other factors we are going to learn. We are going to take the reference directly from Minitab. There is an assistant menu. Wonderful explanation has been given about design of experiment. We are going to do it. The next part is that we are also going to do an example. Using this example, we are also going to perform the design of experiment right from the planning all the way to till the end. We are going to do it like response optimizer and all that. Let's switch back and let's learn the basic thing about Minitab. Minitab design of experiment. Go to assistant and then you have a design of experiment. So the beauty about this tab is that every information what you need to know about, for example, MSA, capability analysis, graphical analysis, hypothesis testing, regression, design of experiment, and capability and control chart, another before after and all that has been given there. One of the thing we are going to learn is design of experiment. So here, if you see here, plan experimentation process. Before even starting the design of experiment, you have a plan. And then there is a tiny definition is given there that before you create a design or collect any data, you should define your objective and outline a general plan for the experiment you want to conduct, because resources are involved and it is very important to know and what's your objective. And then use a sequential, there are some tips are there, use a sequential experiment and then use a problem you want to address through the experimentations, and then define the why, that is response, and what's the goal you wanted to have for why, right? And the small y and big y, right? Establish the budget and a plan for the process of experimentation. Again, it gives 25% of the time you should spend on the experiment and all that, communicate the overall plan and all that, and obtain the approval. This is the basic thing. Okay, so now objective has been determined. Once you do that, so screen with the 6 to 15 factor, that means huge factor. And then you already optimize it, you already done with this screening, and you are going to optimize 2 to 5 factor. It depends on that. If you have screen, you have to do the screening process, you have 16 to 15 factors, that's so much huge, right? And then you can still do that, how you're going to plan the screening process or screening experiment, right? So what you can do, identify the factor and then define the factor. What does it mean? And factor meaning like input, right, that affects the output. It is also called independent factor. And determine the appropriate sample size. Okay, this is very important. And then obtain the approval as such. Okay, once it is screening is done, so you do that, for example, number of factors, let's say you have 5, right? Example 6. So the response is 1, factors are input, that is 5, and then you can give a name, right? For example, factor is temperature, factor is maybe concentration, factor is maybe melting temperature, all that, right? Whatever the informations you have, you can keep adding it, and then you can give okay. It will automatically create the design as such, right? So now let's go further. So now from there you're going to do the screening, and then you're going to conduct the screening experiment. So again, you will validate the measurement system. You trust that all the experiment result, you need to verify whether the measurement system is analysis. For example, let's say you have a variable data, you're going to use GRR, gauge repeatability and reproducibility. It depends upon the type of the data, you're going to pick up the MSA. Okay, this is one way. Another way is that you already have some factors, you screen through quality tools, you wanted to now do optimizations, 2 to 5 factors you have. Then you can identify the critical factors. Again, you do the same thing, like critical 2 to 5 factors that the greatest influence on the response, right? So for the optimization experiment, you need to create a modeling design with the critical 5 factor that have the greatest influence on the response. Okay, then you do that, you're going to create the model. For example, let's say only 2 factors, and you can also increase it also 3 factors, and so on and so forth, right? And then you also have further explanations. The last part is that you also have, you're going to conduct the optimization. So in a nutshell, before you do any experiment, what you're going to do, you're going to define the objective, what you wish to achieve, and then what are the factors, what are the data you have, what's the resources planning, all that come into play. So let's learn the wonderful example which is directly there in the Minitab. I'm going to pick up example of response optimization experiment for a factorial design. You're an engineer assigned to optimize the response for a chemical reaction experiment. You have determined three factors. Reaction time is one factor, reaction temperature is another factor, type of catalyst is another factor. There are three factors. Affect the yield and the cost. No, two, you have two responses, right? One is if yield and another one is cost of the process. All right. And then you want to you wanted to find the factors of maximize the yield. No, you now your objective, now objective is very clear. The the factor setting that maximize the yield and minimize the cost. Like they also given the target, like the cost should be 28 to 35 maximum. Yield is one-sided tolerance they have given. So you have yield, yield should be like 35 to 45, right? Yield you have given 35 to 45. So we can see the ideal optimizations and all that. So now you have the, this is the file name. I'll copy it. I'll go to Minitab and I will close this also as well. Go to file and open worksheet and look in Minitab sample data folder. Have a go and paste it. Open up. So this is the data has been open. So already you have a standard order, run order, center point blocks, and this is the factor one. Maybe I'll call it as a factor one, F1, in order to clearly identify that F1, that factor one, that is input. Temperature is factor two. And then factor three is catalyst. Factor three, F3. And then you have a response. Response is yield is a response. And yield we wanted to improve, right? I'll use the word I. And then cost is also yet another response. Maybe I will call it as R1 here. This I will call it as R2. It will be easily identifiable, right? R2, and we wanted to decrease it. Okay, let's start. The very first thing what you have to do is that you have to create the plan, because we already know that data. Then define custom factorial design. Have a click on it. Factors we are going to give that. So what are the factors we have? F1, F2, and F3. And then if you want full factorial or 2 factorial, because here 2 factorial, right? So now you have a equation 2 the power of L the power of F, right? And then you can just define it 20, 50, that is great, and 150, 200 is great, A and B. So it is uncoded because it's all, it has a text, it has a number. Give okay, give okay. Now this has been created, right? So once it has been created, because it's already there, so it is recreating one more time the same thing. If you wanted to, if you have any cases that it has been done in different days, you can also record it. So define is done. So next part is that you have to analyze the factorial design. Here we need to give the response. That responses is yield is a response and cost is a response. Give okay. And this has been done. Now it says that C, that is catalyst is important according to this Pareto. B is important, that is temperature, catalyst. BC, that is confounded BC, that temperature and catalyst. AC, the time and catalyst is important. AB, time and temperature is not important. ABC, all three together is not important. So these three things are important, right? Once it has been done, now you will be able to do further analysis. What you can do is that you can go to this. You have lot of options now, right? If almost everything you can do, right? Let me start with the response optimizer. Response optimizer, you know, the cost has to be reduced, right? And then decrease, in other word, minimize, right? Yield has to be improved, right? Maximize. No, I'm just giving goal. Yeah, okay. You see that this is like curvature has been there. Now you can find that, you know, if you want that maximum the minimum cost and maximum yield, you're going to have the temperature is 50, 200, and then let me just move it here. Catalyst should be 1, right? Like this, you can still do that experiment, and you can find it out what settings you can have and all that, right? So this is the optimize settings. You can easily get all the informations, everything. And let's say you want to minimize, maximize, you can all that you can do. So let's assume that I'm just making that black dot to black dot, catalyst A to B. What will happen? So the value of cost is increasing, yield also not great. So I'm just keeping back here as per recommendation. And then you can see that these, because based on the catalyst, time and temperature is affecting it. This is one way. Response optimization is great. You can get the value. Another one, what you can also do is that you can also do that the factorial plots. It will give so how much interaction. Let's say cost. Let's say in the cost how it is impacting. You can get the value here, right? Time and cost and all that. If the temperature blue line, if the temperature is low, the cost is low. If the temperature is high, cost is high. Similarly, you can get the catalyst behavior and all that. All the things you can get it. So now what I will also will do is that let's say contour plot. And so contour also interesting. If you see here, and I'm just going with only cost now. One at a time we can go and give okay. So the cost has to be decreased, right? So that means 28. So ideally you will take the temperature very, very low. See, we are holding that the catalyst value, right? We are only talking about only two factor like time and temperature. We are holding the F3, right? So if needed, you can also do it. Now let's see that yield. Yield also you can do the same thing. So for yield, you have again, we are holding the catalyst. And again, if you wanted to include, you can include. So we want yield to be high, right? So you can keep it here. So the temperature you can keep high, right? Similarly, you can just change the variables and all that, change the factors, everything you can very well do it. For example, I can take the factor 2, the factor 1, all that you can do it. The one more thing which you can probably do it is that I think the response optimizer has given all the answer. If you want complete summary, you can give that Q plot. Q plot you can give like so here the cost we are taking is that factor, or maybe I can take yield as a factor. These three you can see here. So this is the value. The time. So if the temperature has been kept 150, we're gonna get the yield is 43. If the temperature is kept 50, 45, and then what catalyst and all that it has been given, all the three cubic one, like catalyst is involved, temperature is involved, time is involved, all the three, and it also gives the responses also as well, right? Response for yield. Similarly, you can do for, I mean, this is for yield. Now you can also do for cost, right? Cost also you have done. Now all the analysis together, we can just sum it up. You remember that our goal is also, they have given the target also as well. Let's do with the target also. What we can do, we can just go here, response optimizer. Let's give target. Let's give target here also. So for the cost, they have given the target is 28 to 35. 28 to 35. And only one value I can give. Maybe I will give that cost should be decreased. So 28, I will start with the 28. And similarly, yield should be high. So 45 we can give. Okay. So that means it gives very precisely that time should be 48.88, temperature should be 150, catalyst should be A, right? So it also gives that interaction, very nice interaction. You can just follow the line and you can just do it, right? All together, let's summarize how we can do. You can go to editor, and maybe I can just go back to the graph. And in the graph, you can just keep all the values together. So that you can do, or you can just double click here and you can find the contour plot, interaction, main interaction, optimization, effect, all that you can easily get to know, right? So I hope you find it this experiment very useful. Please do like, share, subscribe my channel. You have a wonderful day ahead.